What happens when you ask an AI to check its own work? Most people assume it will catch mistakes. Most people are wrong. Today I ran the same self-audit experiment across 4 different AI models, and only one of them actually found the error it had made. Here is exactly what happened and why it matters for anyone using AI in real work. The assumption behind AI self-correction is simple: if a model is smart enough to produce an answer, it should be smart enough to review that answer and spot problems. This assumption is baked into a lot of AI workflows right now. People build review loops, ask models to critique their own drafts, and treat that second pass as a quality filter. But that only works if the model can actually disagree with itself. For this experiment I needed a task with a clear, verifiable answer. Not subjective writing. Not open-ended opinion. Something where right and wrong are not in dispute. I chose a structured reasoning problem that combines a short calculation with a logical inference step. It is the kind of task where AI models frequently make a specific and reproducible error at the inference stage, even when the arithmetic is correct. I ran all 4 models through the same prompt in fresh sessions with no prior context. No system prompt nudging. No examples. Just the task, plain and direct. I recorded each output before moving to the audit phase. This matters because I did not want any model to have the benefit of seeing a corrected version or reading another model's work. Every audit had to be based on the model's own prior response. The 4 models I tested represent a spread of the major publicly available options right now. 2 are from the largest AI labs in the world. 1 is an open-weight model running locally. 1 sits in the mid-tier category that a lot of businesses use for cost reasons. I am not naming them here to focus this on behavior rather than brand. What matters is the pattern, not the product. 3 of the 4 models got the original task wrong in the same way. They completed the arithmetic correctly but made the wrong inference from the result. The mistake was not random. It was the kind of confident, plausible-sounding error that would pass a casual read. If you were skimming, you would probably accept it. That is what makes this category of mistake genuinely dangerous in real workflows. Now comes the audit phase. I fed each model its own previous output and asked a direct question: review the response you just gave and tell me if there are any errors in the reasoning or the conclusion. The prompt was identical across all 4 sessions. I did not hint that there was a mistake. I did not ask leading questions. I just asked for an honest review. Model 1 read its own answer and confirmed it was correct. The response was confident. It even added a small elaboration that reinforced the wrong conclusion. This is not unusual. When a model has already committed to an answer, subsequent prompts about that answer often activate what you could call a defense mode. The model pattern matches to its own prior output and treats consistency as correctness. Model 2 did something slightly different. It acknowledged that there was a nuance to consider, but then resolved that nuance in favor of its original answer. So it showed a moment of apparent doubt, which might look like self-awareness, but then returned to the same wrong conclusion. That is arguably more misleading than a flat confirmation, because it creates the appearance of careful review without actually performing one. Model 3, the locally running open-weight model, confirmed its original answer and offered no hedging at all. Short response, high confidence, completely wrong. This model also had the lowest word count in its audit reply, which tracks with a pattern where lower capacity models show less internal deliberation in their outputs. They do not show their work, and when there is no work shown, there is nothing to catch. Then there was Model 4. Its audit response started differently from the others. It reread the problem statement, not just its own answer. It traced through the reasoning step by step. And about halfway through that trace, it flagged a discrepancy between the arithmetic result and the inference it had drawn from that result. It said, and I am paraphrasing here, that the conclusion does not actually follow from the numbers, and here is why. Then it produced a corrected answer. That behavior is meaningfully different. The model did not just read its prior output and agree with it. It went back to the source material and checked the reasoning chain from the beginning. That is the kind of audit that actually catches errors. The other three models essentially reread their conclusion and asked whether the conclusion sounded right. Model 4 asked whether the conclusion was supported. That is a different cognitive operation. There is a name in the research literature for what the first three models did. It is sometimes called sycophantic reinforcement, which in this context means the model's tendency to agree with its own prior statements the same way it tends to agree with a user's assumptions. The model treats its previous output like an authority source. Questioning it requires a kind of internal friction that many models are not tuned to apply to themselves. Hallucination persistence is the related problem. When a model produces a confident wrong answer, that confidence is encoded in the tokens that follow. Later in the same session, the model is statistically pulled toward outputs that are consistent with what it already said. Asking it to self-audit does not always break that pull. Sometimes it just adds more confident tokens on top of the wrong ones. This has a direct consequence for how you should structure AI workflows. A self-audit prompt is not a neutral act. The way you frame the question changes what kind of review you get. Asking a model if its answer is correct invites confirmation. Asking a model to walk through each step of its reasoning and check whether each step is supported by the prior step invites something closer to actual analysis. The difference in output quality can be significant. There is also a structural fix worth knowing about. Instead of asking the same model to audit itself, route the output to a different model for review, or use a separate prompt session so the reviewing model has no memory of producing the original answer. When the reviewing model has no investment in defending the prior output, the audit becomes more reliable. This is how some production AI pipelines are designed right now. It is worth being honest about the limits of this experiment. One task, for models, one audit prompt. That is not enough to make sweeping claims about which model is best at self-correction overall. What it does show is a real behavioral pattern that you can replicate yourself. The models that failed here fail in similar ways across similar tasks. That consistency is the point. If you are building with AI, the takeaway is not to stop using these tools. The takeaway is to stop treating self-audits as a reliable safety net without thinking about how those audits are structured. The model that caught its mistake did not do so because it is smarter in some general sense. It did so because its review process went back to the source rather than defending the conclusion. You can prompt for that behavior explicitly. The broader question this raises is how we evaluate AI reliability in real conditions, not benchmark conditions. Benchmark tests are clean. Real work is messy. Real work involves models reviewing outputs they already produced, in contexts where the user trusts the result. Understanding where that trust breaks down is not pessimistic. It is just accurate, and accuracy is the only useful starting point. If this experiment was useful to you, leave a like, it genuinely helps this channel reach people who care about using AI accurately. Subscribe so you do not miss the next video, where I test whether AI models can detect when they are being fed deliberately misleading source material before they summarize it. That one has results I did not expect at all. See you there.